Good day, students. Today we are going to discuss few more questions of exercise 5.1. Okay, so we have a question that we have to check the continuity at x equal to 0 of the given function. So let's begin with the proof. So for left hand limit x tends to 0 minus fx is equal to limit h tends to 0 f. For left hand limit we have 0 minus h, right? So limit h tends to 0. Now what is our function at this point? Yes, lambda x square minus 2x. Okay, we have lambda in place of x we have to put 0 minus h, then it is square, minus 2 in place of x we have to put 0 minus h. So limit h tends to 0. So on solving this we get 0. So our left hand limit is 0. Now for right hand limit x tends to 0 plus fx is equal to limit h tends to 0 f 0 plus h. This is limit h tends to 0. Now what is our function? Our function is 4x plus 1. 4 in place of x we have to put 0 plus h plus 1. So on taking limit, okay, we get 4, 0 plus 0 plus 1. We get 1. From this we conclude that left hand limit is not equal to right hand limit. So our function is discontinuous at x equal to 0. So we can say that for no value of lambda, function is continuous at x equal to 0. Now at x equal to 1, at x is equal to 1, right? So limit x tends to 1 minus for left hand limit, okay? So limit h tends to 0. Now in place of x for left hand limit we have to put 1 minus h. So limit h tends to 0. Okay. Now what is our function at this point? Yes, our function is 4x plus 1. 4 in place of x we have to put 1 minus h plus 1. Okay. On solving this we get 5. And for right hand limit we have limit x tends to 1 plus fx is equal to limit h tends to 0 f. For right hand limit we have 1 plus h. Okay, now our function is same. So limit h tends to 0 for 1 plus h plus 1. On taking limit we get 4, 1 plus 0 plus 1. This will gives you 5. From this, we conclude that our function is continuous at x equal to 1. Now, our next question is the function defined by fx is equal to x square minus sin x plus 5 continuous at x equal to pi, right? So, let's start. We have a function fx is equal to x square minus sin x plus 5. Okay. So at x is equal to pi, for left hand limit we have limit x tends to pi minus of fx is equal to limit h tends to 0. Now what is our function? Okay. So it is what? X square minus sin x plus 5, and in place of x we have to put, yes, pi minus h square minus sin, okay, pi minus h plus 5. So on taking limit we get pi minus 0 square minus sin pi plus 5. So it will gives you pi square, okay, plus 5. So our left hand limit is pi square plus 5. Now for right hand limit, we have limit x tends to pi plus fx is equal to limit h tends to 0 pi plus h square minus sine pi plus h plus 5. Okay, on taking limit, we get pi square plus 5. From this, we conclude that left hand limit is equal to right hand limit. So, our function is continuous. Now, we have another question. Find all points of discontinuity of function f where fx is equal to sin x upon x if x is less than 0. X plus 1 if x is greater than equal to 0. Okay, so at x is equal to 0, we have to find all points of discontinuity. So for left hand limit x tends to 0 minus fx is equal to limit h tends to 0. Okay, for left hand limit we have 0 minus h. Okay, now at this point we have a function sin x upon x. Okay, sine. Okay, now in place of x we have minus h upon minus h. Okay, in class 11, students please focus. In class 11 we just learned about this concept, and the value of this sine minus h upon h is 1. Okay, now for right hand limit we have limit x tends to 0 plus fx is equal to limit h tends to 0 f, and for right hand limit we have 0 plus h, right? So limit h tends to 0. Now at this point we have our function, yes, x plus 1. So we have our function x plus 1. So in place of x we have 0 plus h, that is h plus 1. On taking limit we get 1. So from this we conclude that our left hand limit is equal to right hand limit, and at 0 of the value for our function is 1. Okay, so we can say that left hand limit is equal to right hand limit, and at 0 the value for function is 1. So our function is continuous at x equal to 0. Now in this question we have to examine the continuity of f where f is defined by fx is equal to sin x minus cos x if x is not equal to 0, minus 1 if x equal to 0. So at x is equal to 0, left hand limit, okay, so limit x tends to 0 minus fx is equal to limit h tends to 0. So in place of x we have to put 0 minus h. So limit h tends to 0. At this point our function is sin x minus cos x. Okay, so in place of x we have to put minus h and minus cos minus h. On taking limit we get the value for this is equal to minus 1. So our left hand limit is equal to minus 1. Now for right hand limit, limit x tends to 0 plus fx is equal to limit h tends to 0. Now for right hand limit, in place of x we have to put 0 plus h is equal to limit h tends to 0 sin h minus cos h. Okay, on taking limit and solving this expression, limit h tends to 0 sin h minus cos h, we get minus 1. Now the value for function at 0 is also 1. So we can say that our left hand limit is equal to right hand limit. Okay, so we can say that our function is continuous at x is equal to 0. Now Our next question is, show that the function defined by fx is equal to cos x square is continuous function. Okay, so let fx is equal to cos x square. We observe that the function cos x square is defined for every real number. The function f may be thought of as a composition. That means a composite number. GOH of the two functions g and h, where gx is equal to cos x and hx is equal to x square. Since both g and h are continuous function, therefore f is also continuous function. Okay, with this we can prove that the function defined by fx is equal to cos x square is continuous function. With this, our exercise 5.1 get completed. Students, I hope that you all understood the concept and exercise 5.1. You have to practice NCERT questions. Till then, thank you.